Hello students, in this video I'm going to discuss real numbers versus imaginary numbers. Real numbers are numbers that we've talked about before, such as counting numbers, which are like 1, 2, 3. They're also called natural numbers. Then we also include the whole numbers as part of the real number set. Whole numbers are all the natural numbers, including 0. And then we progress to the integers, which are all of the whole numbers and their opposites. That includes the negative numbers. And then we have rational numbers, which are numbers that can be represented as fractions, like 1/2, 2/3, even 5, because 5 over 1 is a fraction. And then lastly, real numbers include irrational numbers. Irrational numbers are like the square root of 2, the square root of 5, pi, numbers that cannot be written as a fraction. These numbers, real numbers, can be written on a number line. And you can actually measure the distance between real numbers. You would just take the farthest right number minus the farthest left number. Imaginary numbers cannot be represented on a number line. Imaginary numbers consist of the square root of -1. The square root of -1 is not a real number because there's no number that can, when you square it, will equal a negative number. So the square root of a negative number just does not exist. What we utilize is in mathematics, and so we've given this um, representation a symbol, and that symbol is I. I simply represents the square root of -1. Now, there are different powers of 1. If I take just the I to the first power is simply just I. Anything to the first power, it's just itself. If I take the square of the square root, remember that the square undoes the index. So if I'm working with imaginary numbers, if I'm allowed to use this square root of -1, then I'm allowed to take the square of the square root of this -1, which would undo the square root and give me -1. So the I to the power of 2 simply equals -1. Again, if I'm working with imaginary numbers, I can take the third power of I, the third power of the square root of -1. Now, when we break down powers, if they have the same basis, I simply add the exponents. So I could break the square root of -1 to the third power into the square root of -1 to the second power times the square root of -1 to the first power, because these powers have to add back up to what my original power was. Well, we already discussed how the square root of -1, the second power, equals -1, and we've already discussed how the square root of -1 to the first power is just I. So I to the third power would equal -1 times I. I to the third power equals -I. And lastly, I to the fourth power. Well, I could, again, break that up into two separate factors. Square root of -1 to the second power times the square root of -1 to the second power. Again, if I add my exponents, they have the same base. I can just simply add my exponents to get the 4. We've already discussed how the square root of -1 to the second power equals -1 because the 2 undoes the index. Same on this one, the 2 undoes the index. So now I have -1 times -1, which equals +1. So these are the powers of I, and these are powers that you would want to memorize the values of. Now, when I go to the power of, to the fifth power, I'm going to repeat the process all over again. If I have the square root of -1 to the fifth power, I could break that down into the square root of -1 to the fourth times the square root of -1 to the first. We've already discussed how the square root of -1 to the fourth equals 1. And so 1 times I equals I. So the square, so I to the 5th power equals I. See how we just repeat the process over again? This is going to be I to the 5th. This would be I to the 6th, I to the 7th, I to the 8th. And I repeat again. 9, 10, 11, 12, and repeat again. It just repeats over and over again. So knowing the first 4 powers of I is beneficial, and that will give you all the powers of I. I hope this has been helpful. Have a great day.